Hello friends, welcome back again today. We're going to move on with our discussion. Today we are going to start up a new topic known as current limiting. So today we are going to limit the current in the circuit. Suppose you have a load which is rated at a lower over the lower current and from compared to the current which is coming from the source. So now how are you going to control that current and to give that load the maximum required current? Okay, it is what we are going to discuss. So without any delay, let's start. Current limiting is a technique used to prevent excessive current from flowing in an electrical circuit. Okay, it is essential for protecting components from damage due to overcurrent, which can result from short circuit, okay, power surges or other anomalies. So we are going to prevent excessive flow of current in the circuit, so that by preventing that excessive flow of current in the circuit, we are going to give the circuit the maximum, the required current the circuit uh, is requiring, regardless of the amount of current which is coming from the source. Okay, that is what, in simple terms, that is what current limiting means. So we are going to start up investigating from Ohm's law, and we'll move on until we reach where we're supposed to reach. So last time we discussed about a resistor when connected like this. We said that a resistor offers opposition to the flow of current. Okay, it offers opposition to the flow of current. Then we investigated a resistor using Ohm's law, and we say that Ohm's law mathematically is given by voltage is given by current times the resistor. So this is how we investigated Ohm's law mathematically. So if we want to get the current will be equal to voltage over the resistor. Okay. So this is what this one. So which it is telling us something here, that the current and resistor are inversely proportional. Okay. Which meaning that if the resistance increases, the current must reduce. And if the current increases, the resistance must be reduced. So that is how they work. Then, when this phenomenon of current increasing, resistance increasing, current reduces happens, the voltage must remain constant. That is very important to know, that when all of this is happening, resistance must be remain constant. Okay, that is what will happen. If we use a single resistor like this to control the flow of current, depending on the value of the resistor, the single resistor cannot block that big amount of current. And also we need also to have another mechanism of also having more and more resistors in the circuit, so that it can prevent large amount of current to not flow. Also, like a single resistor of high value can also do the work, but let's also investigate another type. Now if we connect two resistors in series like this, R1, R2. Now if you connect the two resistors in series like this, we say that for us to get the total resistors in the circuit, the total resistance is equal to resistor 1 plus resistor 2. Okay. Also we say that the supply voltage across each resistors, it divides. Okay, it divides the resistor. So the total V total will be equal to V1 plus V. So for us to get the total voltage in this circuit, we sum up this voltage 1 plus voltage 2, will get the total voltage flowing in this the circuit. The total voltage in this circuit, not flowing, the total voltage in this circuit. Okay. So saying that this voltage, when it sum, must equal to the input voltage. Okay. Now when two resistors are connected like this in series, you see the total resistance is equal to R1 plus R2. So it means the value of the resistance will add up. So when it add up, that means the current will continue reducing the value of current in that circuit. Okay. So when the resistors are connected in series, so we need to keep these two formulas, that when we put two resistors in series, the values will sum up and the voltage will be investigated using these formulas. Now let's take an example of a load. Let's say we have a load rated at 3 volt. Okay. And the current load IL is equal to 20 milliamps. Now the available source we have is 5 volt. Let's use 5 volt, 9 volt. Okay, any can be any. Now we need to power this 3 volt, this 3 volt LED. Let's use an LED to this source. You need to connect this one to this source. So we need to power this LED to this 3 volt 20 milliamps LED from 5 volt. Okay, now we are from up here we are from investigating that when the resistor increases, the current reduces. When the current increases, the resistance reduces. So meaning that we can use a resistor to control the flow of current in a circuit. By connecting a resistor in series with the load we want to protect to control the current, we can control the current in the circuit. So the current limiting we are going to investigate, we are going to use a resistor as current limiting device. Okay, so we are going to use the resistor to control the flow of current in an electrical circuit. Okay, now having knowing that for us to control the current in the circuit, the resistor must be connected in series with the load we want to protect. So we want to protect this LED to not blow up when we power it with 5 volt, though it is rated 320 milliamps. Okay, so we need now, we don't know the value of this resistor here, so we need to calculate the value of this resistor so that we can buy a resistor and connect it in series with this LED so that the LED does not blow up. Now how do you calculate the value of that resistor is what we are going to investigate right now. Now from here we can see that the voltage across this resistor and the voltage across this LED. Okay, if you want to get the total voltage, will be equal to V total will be equal to V1 plus V2. Okay, V1 plus, so the sum of these two must give us this voltage. So let's investigate that. We'll add up the voltage we'll get here and the voltage we'll get there. So when we sum up, must give us 5 volt. Okay, let's move on. Then now the input voltage we know is 5, so that one we can take, we can say, we can equate this V total to be V in. Okay, V in, then V in is 5 volt is equal to V1 we don't know. Okay, V1 we don't know plus V2. Now V2 is the LED rated voltage, so it is 3 volt. Okay, now we know V in, V2, and we don't know V1, so we need to get V1. So it will be 5, we take 3 on this side, 5 minus 3, it is positive. When it comes to this side, it becomes negative, so it is equal to V1. So V1, 5 minus 3 is equal to 2, so V1 is equal to 2 volt. So the voltage at this point here is 2 volt. Okay, so Vt is equal to V1 plus V2. Now we have seen that for the LED is 3, and for this one at this point, at this resistor is 2. When we add these two, it gives us 5 volt. Okay, which is correct. Now let's move on. Now let's calculate the value of the resistor now. Okay, now having knowing that the V1 will be equal to IR, Ohm's law, we just apply Ohm's law. So we now concentrate on the resistor, the value of the resistor. Okay, V1 is equal to IR, so current times resistance. So we know V1 is 2 volt. Okay, we have calculated here. We got it as 2 volt. We don't know the current, but we will use the current of the LED, 20 milliamps. So we take V2 is equal to current, which is 20 milliamps, times the resistance. So the resistance is unknown. So for us to get the value of the resistor will be equal to voltage over the current. Okay, when we substitute, it will be 2 over 20 milliamps. So it will be 2 over 20 milliamps. Okay, also so we convert this milliamps to amps. 20 times 10 raised to 10 power negative 3. Okay, so when we do this one in a calculator, it is giving us 100 ohms. 100 ohms. So 100 ohms. So the value of the resistor which will be connected here, so this resistor is 100 ohms. So you look for 100 ohm resistor to connect it in series with this LED. So it is going to light up very, very well. So it's going to control the current which is going to flow toward the LED. Now there is another configuration. There's something else we need to talk about. It is the power dissipation. So the resistor dissipates power in the form of heat. Now, how are we going to choose the value of that resistor? Knowing that power is equal to voltage times current, or power is equal to current squared times the resistance. So what we can do, we can use any of the formula. Let's use this one, this VI, so that next time we'll use this one. Okay, then the voltage here, the voltage we shall use will be 3. So so it will be 2 volt, okay, times 20 milliamps. So this one will give us 0.04 amps, 0.04 watt. So this is the power dissipated in that resistor. So for us now, the normal resistor, so you should know that the normal resistor is a quarter watt. It's quarter watt, which is equal to 0.25. So you check, you see, a normal resistor is a quarter watt, so 0.25. So 0.04 is below 0.25. So we are going to check a normal resistor. Okay, so that is what the brief we want to say about this one. So in another scenario, we will calculate. You'll see that the value of the resistor, the power dissipation, is much greater than this. We'll see what we can handle in that case. So that is the brief we can say about this one. This part 1. We still have 3 more to investigate. Thank you.